Today, we discuss exponents, multiplying exponents, dividing exponents, exponents of exponents, negative exponents, and even fractional exponents. We've got a lot of rules to cover, so let's get started. Welcome to Perfect Score with Carl Rosenthal, your source for SAT and ACT math preparation. Come for the math cat, stay for the extremely ill-advised facial hair. So, when you deal with exponents on the SAT and the ACT, you have to know all your rules cold. So let's start with multiplying exponents with each other. Let's say you're multiplying two exponents. X to the power of A times x to the power of B. When you do that, you keep the base, but you add the powers. This becomes x to the power of A plus B. Therefore, if I asked you, what is the value of x to the power of 4 times x to the power of 3, all you would do is keep x, then to the power of 4 plus 3, and that equals x to the power of 7. Next, what if we divide exponents? What if we have x to the power of A divided by x to the power of B? Well, just like in the multiplication example, you do keep the base, but instead of adding, you subtract the powers. This becomes x to the power of A minus B. So, if I ask you, what is the value of x to the power of 6 divided by x to the power of 2? This becomes x to the power of 6 minus 2, or x to the power of 4. Now, what if we have the exponent of an exponent? So say x to the power of A, and that whole thing is raised to the power of B. In this case, you multiply the exponents. We have x to the power of A times B. So, what if I said, what is the value of x to the power of 3 to the power of 3? Well, we have 3 and 3. We multiply them. This is x to the power of 3 times 3, or x to the power of 9. Now, what about a negative exponent? What if I said, what is x to the power of negative 1? Well, the trick is, if you have a negative exponent, all you have to do is change it from numerator to denominator, or vice versa, and make the exponent positive. Therefore, this example would become 1 over x to the first power, or 1 over x. So what if we had x to the power of negative 3? Well, this then becomes 1 over x to the power of 3. But what if I said to you, I want to know what 1 over x to the power of negative 4 is? Well, this denominator now becomes a numerator, and the power becomes positive. This just becomes x to the power of positive 4. That's how you deal with negative exponents. And finally, what do you do if you have a fractional exponent? What if we had x to the power of 1/2? Well, the numerator and the denominator of that fraction mean very specific things. Basically, the denominator becomes the index of a radical. What is an index? Well, it is the value of the root you're taking. Here, the denominator is 2. So we're taking the second root of x, or the square root. This actually translates into the square root of x. Now what about the 1? Well, the whole thing then is just raised to that power. So this is just root x. So the full rule is this. If you have x to the power of A over B, well, this becomes then the b root of x to the power of A. And this can also be written as follows: the b root of x to the power of A in there. These two are equivalent. So let's test this. If I say, what is the value of x to the power of 2/3? Well, this 3 becomes the index of the radical. It becomes the cube root of x squared, or the cube root of x squared, like that. Both are correct. I know this is a lot of information to take in, so feel free to stop this, rewind, and watch as many times as you need to. As usual, I have selected 4 problems, 2 from the SAT and 2 from the ACT, to help us understand and master these problems. Let's get that perfect score. Come on. So this one is number 8 from the ACT. A calculator is permitted, but I don't think we need it. All we have here is a multiplication problem. Basically, we have 2 monomials, 2x to the 4th times y, times 3x to the 5th times y to the 8th. All we have to do is multiply integers with integers, x's with x's, and y's with y's. First things first, what is 2 times 3? 2 times 3 is 6, so we can cross out f and j. That gives us 5. Then we want to know what is x to the 4th times x to the 5th. Now remember, when you multiply exponents, you add the powers. This becomes x to the power of 4 plus 5, or x to the power of 9. We can now eliminate option K, which gives us x to the power of 20. Next, we consider the y's. This is y to the power of 1. There's no power, we assume 1, times y to the power of 8. Again, we're multiplying, so we add the powers. We have y to the power of 1 plus 8. That is y to the power of 9. Our answer is going to be H. Nice. We now have another ACT problem, but instead of multiplication, this looks like we are trying to find the power of a power. We have 4x squared, the whole thing to the power of 3. Now, each element of this monomial, 4 and x squared, must be raised to the power of 3. So we start with 4 to the power of 3. And you're allowed to use your calculator, and we see that 4 to the power of 3 is 64. So we know the integer value here must be 64. We can cross off h, j, and k that give us 12, 12, and 4. And then we consider x squared to the power of 3. When we have this, don't forget, the power of a power means you multiply the powers. This becomes x to the power of 2 times 3, or x to the power of 6. Our answer is going to be 64 x to the 6th, and that's G. This problem here is from section 3 of the SAT, number 11. This is the point where it starts to get kind of hard in the SAT. So we have a lot of things going on here. X to the negative 2 times y to the 1/2 over x to the 1/3 times y to the negative 1. The first thing we should do is deal with the negative exponents. Remember when I said when you have a negative exponent, you can change it from numerator to denominator and make it positive, or vice versa? Let's do that. We start by considering this x to the negative 2. We know we can move it down to the denominator and make it x to the power of positive 2. So let's do that. On top, all that's left is y to the 1/2. And on the bottom, we then have x to the power of 2, which is this, but made positive, times x to the power of 1/3 times y to the power of negative 1. Well, now we should move this y to the negative 1 up to the denominator and make it positive. So we now have y to the power of 1/2 times y to the power of 1, so just y, over x squared times x to the power of 1/3. Now, let's deal with these fractional exponents. We know that y to the power of 1/2 will equal the square root of y, because this denominator 2 is the index of the root. That becomes the square root of y, and that's just going to be multiplied by y. So let's just say y times root y. If you look at our answers, 3 of our options do have y root y. 1 does not. We can cross it out. And now, on the bottom, that x squared remains. But what does x to the power of 1/3 become? Well, the 3 of the denominator here becomes the index of the radical. This becomes the cube root of x. This is our final answer, y root y over x squared times the cube root of x. The answer is going to be D. And now we see our hardest problem yet. This is also from the SAT non-calculator, number 15, probably the hardest question in the test. Let's tackle it. What is negative 4x cubed to the power of 2/3? The first thing we should do is distribute that power of 2/3 to both the negative 4 and the x cubed as follows. Let's rewrite this as negative 4 to the power of 2/3 times x cubed to the power of 2/3. Now we have two fractional exponents. What is negative 4 to the power of 2/3? Well, let's make this 3 in the denominator the index for our radical. This is the cube root of negative 4 to the power of 2. This is how you translate this exponent of 2/3. And now, x cubed to the power of 2/3, when we have an exponent of an exponent, we can multiply them. This becomes x to the power of 3 times 2/3. What is 3 times 2/3? Well, you can look at it as 3 over 1 times 2 over 3. The 3's cancel out. It is just 2. This is x squared. We know our answer is a cube root of negative 4 squared times x squared. Well, unfortunately, we don't actually have that, so let's keep working. Let's continue with this. What is negative 4 squared? Negative 4 squared is negative 4 times negative 4, so positive 16. This becomes the cube root of positive 16, and all that is times x squared. This is correct, but is this one of the options? Unfortunately, no, it's not. So, can we keep simplifying the cube root of 16? Well, indeed we can. Can you think of a perfect cube that is a factor of 16? What are some perfect cubes you know? Well, 1 cubed is 1. Well, 1 goes into everything, so we can't use that. 2 cubed is 8. Well, 8 certainly goes into 16. So, let's rewrite this radical as the cube root of 8 times 2. Because 8 times 2 is 16. This we continue to simplify as the cube root of 8 times the cube root of 2. Now we know what the cube root of 8 is. The cube root of 8 is 2, because 2 cubed is 8. 2 times 2 times 2 is 8. So this becomes just 2 times the cube root of 2. So our answer needs to combine x squared and 2 times the cube root of 2. In other words, 2x squared times the cube root of 2, or C. Okay, thank you for joining me for one more video. As always, please subscribe to my channel, hit the like button, join me next week for another video, and together, we'll get that perfect score.